Hi, this video is for the Caribou Mathematics Contest. I'm going to show the solution for the February 2016 Grade 5-6 Contest, question 14, which also came up in the Grade 7, 8, 9, 10, and 11, 12 contests. So the question is, at a school running track, Peter runs clockwise around the track, making one lap every 50 seconds. Starting from a point directly opposite Peter's starting point, Sarah runs counterclockwise, making one lap every 60 seconds. How many times do they pass each other in the first 10 minutes? Okay, so we know the duration of them running on the track is 10 minutes. But what their lap times are given to us in seconds. So we want to convert it to seconds. So we want to convert the 10 minutes into seconds. Now we know that 1 minute is 60 seconds. So we will have 10 times 60 seconds is equal to 600 seconds. Alright, and we know Peter does one lap every 50 seconds. So in order to find the number of laps that he does in this 10 minutes, we will do 600 seconds and divide that by his 50 seconds per lap, which we will just write with an L. So 600 divided by 50 is then 12. Then the seconds cancel, and then we have 1 divided by 1 over L. Well, that just gives us L. So we have 12 laps. And for Sarah, we know that she does one lap every 60 seconds. So we will do the same thing, 600 seconds, and divide that by 60 seconds per lap. And 600 divided by 60 is 10. So 10 laps. Okay, so during this 10 minutes, Peter does 12 laps, and Sarah does 10 laps. Alright. Now, from our question, we know that they run opposite from each other. So it says that Peter runs clockwise, and Sarah runs counterclockwise. Now, because of this, the solution to this problem, which is the number of times they pass each other, it only depends on Peter's and Sarah's relative speed towards each other. And it does not depend on, for example, Peter's absolute speed. So if Peter were to run a certain amount of speed slower, if Sarah were to run that same amount of speed faster, their relative speed towards each other would be the same, and therefore the number of times they pass each other in this 10 minutes would also be the same. Alright. Now, in an extreme case, what we can do is we can have Peter do no laps, so he would be at 0. And then, to make up for this, Sarah would then run the number of laps that Peter would run, which is 12 laps, in addition to her already running the 10 laps. Now, this would keep their relative speed towards each other the same, and the number of times they pass each other would then, of course, also stay the same. So therefore, Sarah would be running 10 laps plus 12 laps, which is equal to 22 laps. And Peter would just be standing still. Well, if Sarah runs 22 laps, that means that she must pass Peter, they must pass each other 22 times. So therefore we know the answer is 22. Now the key to solving this problem is recognizing how it is possible to alter the question in such a way that the solution, which is the number of times they pass each other, that will stay the same. Now how we did this is we were able to change Peter's and Sarah's speeds. So like we had Peter having no speed, staying in the same position, and Sarah making up for that, also in addition to her own laps, running his laps, which then kept their relative speed towards each other the same, and also kept the solution the same of 22 laps, giving as a total distance and 22 passes. If you'd like to know more about this contest, please feel free to visit our website at cariboutests.com.